Calculate the F statistic for this example ANOVA. We have four factors, 87, 89, 91, and 93 octane. We have our horsepower data here. And again, the question we're asking is, does the change in octane affect the horsepower output of an engine? So we're going to do this ANOVA calculation to test the hypothesis. Is there a difference in the means? So we've got this set up here with our ANOVA worksheet. We're going to calculate each of these boxes. We'll get to an F statistic, and then we'll be able to determine whether or not to reject or fail to reject. So the first step in calculating variation, this leads to the standard deviation. We're not calculating actually standard deviation, but just variation, is we're looking for the variation in relationship to the mean. So in this case, we're going to start off with this calculation here, this sum of the squares for the between within each treatment. So we're going to take each data value and we're going to subtract the mean from it. Then we're going to square that. Then we're going to add it together. Okay, so we're getting the deviation squared. What we'll need first is the mean for each of the octanes. So let's see how we could do that with Google Sheets. So I'm going to click here where I want to put the mean in this little blue box. I want to get the average of these numbers. One way to do it is to click on the ellipsis, the three dots here. It gives us more, and we want to pull up functions. The function we want to use for the mean is average. I don't know why they don't call it the mean. Maybe that's too many m's or something, but average. So we're going to calculate the average. You can put in your different values. Since we've got it in a nice column here, what we can do is just click on the first one, click and hold. And notice it highlights it. And as I'm holding down, I'm dragging to the bottom, and I want to include all these numbers in the average. I release it, and then I just have to hit the enter key, and it now has calculated the average of these numbers. Now the number 169.7 is not what's in this square, this cell. It is actually a formula for that calculating the average. Now what I can do, instead of having to do that each 3 more times, is I can copy this cell, and it's going to copy the formula. So I'm going to do a control. So with it selected, I do a control C. Notice as I do a control C, it has the dashed line around it, which means it was copied. I come to the next one and I do a control V, and that pastes the formula. Notice now we're getting the average of the D column for 89 octane from D3 down to D12. And then we'll do control V again and control V again. Now you should be coming up with the same values as long as you've got the same values in here. The calculation is the calculation. Now when we were doing this in class, occasionally we'd have a little difference. My guess is that not all of the numbers got put in here. So instead of going from 3 to 12, maybe you only highlighted from 4 to 12, or maybe you did 3 to 11 or something. Maybe you had one number that was left off. That could make the difference. Okay, but if we have the same numbers and we have all 10 of them in the calculation for the average, we should all have these same values. Okay, so that's our first step. The next step is to get the deviation squared. So we're going to come to this square, and what we want to do is we want to take 168.8, we want to subtract the mean, and then we want to square that, because this is the calculation over here that we're doing. Okay, so we'll take each data value, subtract off its mean, and square it. So a way to do that is we'll hit the equal sign, and that will start an equation. So we come in here, equals, notice it comes there. I want to use this number, so remember we're going to have a parentheses, and then I want this number here, it's highlighted, B3. subtract this mean. I'm going to close the parentheses, and then I'm going to square it. So I do a shifted 6, the number 6, and that gives me this little caret, which is the exponent key. I'm going to do square. And before I leave this box, I'm going to back up here, and I can work in either the function window up here, or I can work right into here. I'm going to put a $ there, and you'll see how this works. This is going to freeze this cell, so it's always going to give us B14. At least the 14 part will always be. B will change as we're going to copy this over, but you're going to see there's a reason for doing that. Put the $ in front of the 14, not in front of the B, just in front of the 14. And now the suggested fill, we could accept that. You're going to see that it's actually correct. They were right. I'm going to delete it because I want to show you the other way. What we can do is we can copy this cell down, and notice how the cursor changes as I get around this. This will, if I click, I can move it. So it changes. What I want is I want this plus sign, and I want to click and hold the left click, left mouse button, hold it down. So this is going to copy it down to here, to 12, and notice from 3 to 12, I now have you can click on any one of them. It's taking the data value minus the mean, which is in cell B14, subtracting them and then squaring it. And finally, what we're going to want to do with this is we're going to want the sum of all of these. So while I'm here, let's go ahead and do that. And we can do that. There's a special feature, a function I've called sum. And we're going to take the sum. Just like we did the average, we could do the sum. And again, we select these cells. So I come to the top or the bottom, whatever you want to start, and you click on it, click and hold, drag so that you've got them selected, and let go, and then we'll hit enter. It just took it summed all of those, and we don't want its suggestion, right? So we're going to do that. Now we could do that for each of the other columns, or we could just copy. So I click and hold. I'm selecting these. I'm going to do a Control C, and then I come here, I click here, and I do a Control V. That's what? Shouldn't have done that. Control C, Control V. That's better. I don't know what I did there. I must have done a cut and paste. It's not what I wanted. So this is what I want. Sometimes we get these errors. Let's see, go up here, and notice now this is referring to the D column, which is 89 octane, and it's subtracting its mean, which is in D14. So that's why we didn't put the $ on the D. We only put it on the 14. And we can continue. It should still be in memory. If we Control V, we're copying over the formulas, not the values. So now we've got all 4 copied off of the first one. Okay, so that's good. What we need to do now is to finish this off. We can get the sum of the squares of the error, which are these 4 numbers. And so I'm going to go with an equals down here, the sum of the squares of the error, and I'm just going to click on each one. I'm going to click on this one and then put a plus. This one and plus, this one and plus, this one, no plus, just an enter. So it will add those 4 numbers together. You could do it separately, just on the calculator to check, oh, that's what it's doing. Again, it always makes these suggestions. We don't want it for there. We'll talk about degrees of freedom in a moment. The next thing we need is we need to do the same thing for the treatment groups. Okay, and how that's going to work, we're using this formula over here. So we're going to take, in this case, since it's between the treatment, we take the mean of each treatment, we subtract off something called a grand mean, or I would call it the mean of the means, and then we're going to square that. That's our variation there. Since there's the mean is comes from 10 sample datas, we'll multiply by that 10. So it's going to be 10 times the treatment mean minus the grand mean squared. So let's see how that all works. The grand mean is a mean of the means. So we're going to go there, we'll click on that grand mean, the darker blue. We're going to go pull up a function and we're going to get the average. Now I'm just going to show you this one. You could select the column, but I'm just going to click on each one. So I'm going to put this value, comma, this value, comma, this value, comma, this value. So it's going to take the average of those four numbers, the average of the averages, the mean of the mean. Okay, so that's a grand mean. Then what we do is in this deviation squared section, we're going to follow this. It's got a little changes. We're going to multiply each one by the sample size, which each sample is 10. And so we will do that. So the way we can do this is we will put in our equals. We'll put 10 times parentheses. We click on this one because that's the mean we want. We subtract the grand mean. And in this case, we want to keep this one. We're going to copy over to each of these. I'm going to show you to keep this the same. We're going to put a $sign there. We're actually not going to have to change the 16, but I'm going to do that anyway. I want to freeze and say this is, I want to always be subtracting cell B16. Okay. And then I'm going to square that. Gives me that number. We're going to round these anyway, but I'm now going to Control-C, copy it, and I'm going to paste it here. And you're going to see what it's doing now. If you look at the formula, it's referring to D14. So this mean is still subtracting B16, which is the grand mean, multiplying, squaring, and multiplying by 10. Okay. So we can just do Control-V. And for each of these, we're pasting. And remember, what we're pasting is the formula, so that's why we're getting different numbers. So these are the squared deviations using the mean of each factor and the grand mean. The sum of those goes here, sum of squares of the treatment. So here we can put a sum. We could add them individually as well. So again, there's always more than one way. I do that, comma, select this one, comma, select that one, comma, select that one. Enter. I just added those four numbers together. Okay. The next thing we need to talk about is degrees of freedom. We're just moving along. So the degrees of freedom for the treatment is A minus 1, where A is, it doesn't tell us here, but A is the number of treatments, the number of factors. And in our case, A was equal to 4 different octane levels. 4 minus 1 is 3. We're just going to enter that here. No great formula needed. Oops, could use it. Degrees of freedom for the error comes with this formula. So A, we already talked that A is a number of treatments. So in this case, it's going to be 4. Number of the sample size of each group, which is 10. Subtract 1. So that gives us 4 times 9, which is 36. Again, you could have done that with the formula, I suppose, in here, but it's just as easy to work it out and say that's 36. Now, our next few steps are pretty straightforward. We're going to calculate the mean squares, and according to these formulas down here, it's just a ratio. So what we're going to take for the mean squares of the treatment, it's really already set up like a fraction. We're going to take 829 divided by 3. So I'm going to go equals. I'm going to take this cell divided by this cell. Enter. 609. For this one, I'm going to take 147.9 divided by 36. Again, whatever is in this cell. So I'm going to go equals this cell divided by this cell. Enter. There's that number. And the F statistic is the mean squares of the treatment divided by the mean squares of the error, which means the green divided by the yellow. So again, I just put in this formula equals this cell divided by this cell, 148.4. Okay, so that's our F statistic, and it will tell us whether we reject or fail to reject. The last step we need to do is to use our NumWorks calculator to get the F statistic. And again, we could fill all those things in, all these numbers over here. I'm going to go ahead and write in the F statistic as 148.4. Last step is to take our NumWorks calculator. We're going to come down to distributions. And if we go to the very bottom, there's this thing called a Fisher's F. That's what we're dealing with. We need the degrees of freedom of the numerator, and we calculated that was 3, right? 4 minus 1 is 3. We put that in here. Degrees of freedom of the denominator, which we calculated as being 36. Put that in there. And we go to the next. This is what the Fisher's F distribution, or what an F distribution looks like. When we're looking for what to reject, remember we want the tails. This will always, and notice there's really not a tail here on the left. These are always going to be right-tailed tests, so I'm going to go to the right. Now we didn't set up a level of significance that we were looking for, but let's just say it's a 5%. You'll see it doesn't really matter. We could have done a 10%. We could have done a 1%. If we do a 0.5%, what we do is when we put OK, this is the F value that if it's bigger than this, we would reject. And notice ours is 148. Here's 5. 148 is like way down the line. It's definitely in the rejection region. Okay, so this gives us our rejection region, and we would reject any number. So this is called, let's do this officially, the F critical. Is equal to 2.87. And if we are larger than that, which we are, 148 is our F test statistic is 148.4. We are larger. This is definitely larger than 2.87. So we are able to reject the null. So that is the test. That's how you can use happened here. You can use a Google Sheet to make those calculations. Oh, I forgot to make a copy of this, but that's okay. Thank you very much.